2.1 Introduction to Exponent Laws and Scientific Notation. So we're going to cover two different things here. Okay, so when we see an exponent written like this, and say for example that this is like the lines on your paper, okay, we have a big number and that's going to be called the base. Then we have a superscript smaller number and that's called the exponent. So if we have an example like this, 5 to the exponent 6, this is written in exponential form. Okay, so this is called exponential form. And how we expand it, so for expanded form, is we would take that base and we would multiply it by itself 6 times. Right? 5 to the exponent 6 means multiply 5 by itself 6 times. Okay? So example 1, identify the base and the exponent in the following expressions, and then write each in expanded form. So for the first example, we have m to the 4. So the base is m, the exponent is 4, and how we write this in expanded form is we would take the base and we'd multiply it by itself 4 times. So m times m times m times m. Now the second example, the base is 3, the exponent 6, and in expanded form, we're going to write 3 times itself 6 times. So we're going to get 3 times 3 times 3 times 3 times 3 times 3. That's 6 times. Okay, so practice number 1. Identify the base and the exponent of the following expressions, then write each in expanded form. So g to the 5, the base is g, the exponent is 5. In expanded form, we're going to write g multiplied by itself 5 times. So 1, 2, 3, 4, 5. Okay. Now we have 4 to the 3. The base is 4, the exponent is 3, and the expanded form is 4 times 4 times 4. Okay, now we're going to move on to scientific notation. So that was just an introduction to exponents and how to work with them. Now, scientific notation is a method used to express very large or very small numbers that are difficult to say and write. And this makes these numbers more manageable. Okay, so the mass of the Earth is approximately this big in kilograms. We would never write this as like this big of a number. I don't even know. This would be thousands, this would be millions, this would be billions, and then these numbers are so big that they're unmanageable. So because this is a very large number, we would actually use scientific notation to express it. Now, the diameter of an electron is this big in centimeters. That's a very, very, very small number because we have a decimal there. So we have so many zeros after this decimal that this is such a small number. We're going to learn how to manage these. Okay, what scientific notation looks like. So if we have this really big number, this is actually called standard form. Let me do this with green, which is an expanded form of the number. That's usually what we see numbers in. Now, if we want to convert this to scientific notation, what ends up happening is we're going to have some number, there's going to be one whole number, then a decimal immediately. Okay, and then whatever units are after the decimal is fine. Okay, so the number must be between 1 and 10. Oh, this is supposed to be here. Okay, so it can be 1 to 9, basically. Okay, and then this is going to be multiplied by 10 to the exponent 24. This is always going to be 10 to some exponent, and it's going to be either positive or negative. Okay, and what this means is that if we had 5.976, so 5, it would have originally been 0.976. What this number 24 is how many times did we have to move this decimal? So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so the original decimal was here, and we moved it to the left 24 times so that we could get a number between like 1 and 10, including 1 but not including 10 out front. So here's the method of writing writing numbers in scientific notation. Okay, move the decimal right if it's a smaller decimal number, or left if it's a large number, until the number is between 1 and 10. Write the number between 1 and 10 and multiply by 10. So it's going to be a number, decimal, whatever it is. We're going to multiply by 10. And then to determine the exponent on the 10, so up here, count the number of times the decimal point is moved. So here's going to be the difference between a very large and a very small number. If the original number was very large, and we're moving our decimal to the left, so remember, this is the original decimal, and this is the new decimal. If we're going to the left, then the number on the exponent will be positive. Okay, but if we're dealing with a very small number, so our decimal is moving to the right, and we'll get into an example with that, then the exponent on the 10 will be negative. Okay, example 1. The speed of light is 299,000 kilometers per second. Express the speed of light in scientific notation. So you'll see how easy this is. This is where the decimal is currently. We're going to go 1, 2, 3, 4, 5 units to the left. So our number is actually going to be 2.99. And our hint here is just have one number in front. If you have two numbers in front, then you're just going to have to move the decimal one more time. Okay, so just have keep moving the decimal until there's one number in front of the decimal. And we said that we moved 1, 2, 3, 4, 5. We moved 5 times. So this is going to be times 10 to the power of 5. That's it. Done. We can put kilometers per second, put an equal sign. Okay, I'm not going to put a therefore statement for this. It's not really a word problem. Okay, example 2. Operations in a computer occur in less than 0.000000012 seconds. Express this time in scientific notation. Okay, so this is the original decimal. We're going to move it so that we have one number in front of the decimal. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want it right there. So our new number is 1.2 times 10 to the exponent. We moved it 10 times to the right. So now this is going to be 10 to the exponent negative 10. And that's measured in seconds. All right, let's do example 3. Write the following numbers in scientific notation. So our decimals here, we're going 1, 2, 3. Okay, so we know this is going to be 10 to the power of 3. We move the decimal 3 units over. So now our number is 1.2563 times 10 to the power of 3. Okay, for 200, our original decimal is here. We're going to move it 2 units. So we know that this is going to be 10 to the power of 2. Okay. and our number is 2.0. You don't want to just write 2. You want to write 2.0. You want to include at least one decimal there, even if it's 0. I think it's better form. Okay, the next one. 1, 2, 3, 4, 5. So we moved 5 places to the right. So we know that we're going to have 10 to the power of -5. And our decimal is 5.5. So write each number in standard form. So 9.729 times 10 to the power of 2. So this tells me that when we move to the right 2 units, so I get 972.9. So what about B? 3.14 times 10 to the power of 5. This 5 is telling me that we move to the right 5 units. So 1, 2, 3, 4, 5. So I'm going to write this out so we can see. 1, 2, 3, fill it in with a 0. 4, fill it in with a 0. 5, fill it in with a 0. And we get 314,000. Okay, and then C, 4.2 times 10 to the -3. -3 means that we're going to get a smaller number. So 1, 2, 3. So this is where the decimal goes. So it's 0.0042.